T7.13. The amount that households pay service providers for access to the internet varies quite a bit, but the mean monthly fee is $50 and the standard deviation is $20. The distribution is not normal. Many households pay a low rate as part of a bundle with phone or television service, but some pay much more for internet only or for faster connections. A sample survey asked an SRS of 50 households with internet access how much they pay. Let X bar be the mean amount paid. Part A. Explain why you can't determine the probability that the amount a randomly selected household pays for access to the internet exceeds $55. Okay, so the reason why we cannot calculate any probabilities here is because they tell us the distribution is non-normal. Okay, so we couldn't use table A, or we couldn't use normal CDF on our calculator because those features, right, are only applicable to normal distributions. Okay. All right, so we'll just write our answer over here. Because the population distribution is not normal. All right, part B. What are the mean and standard deviation of the sampling distribution of X bar? Okay, this is a perfect opportunity for us to go ahead and use our formula sheet. Okay, so it's a question about X bar. Okay, so the mean is just mu, it's the population mean, and the standard deviation is sigma over root n. All right, so let's write these down. Okay, so the mean of X bar is just the population mean, and the standard deviation of X bar is the population SD divided by square root of n. Okay, so we are told that the mean is 50 and the standard deviation is 20 and the sample size was 50. All right, so 20 divided by root 50 is 2.83. All right, part C. What's the shape of the sampling distribution of X bar? Justify your answer. Okay. So remember in part A, we said the population distribution we know has a non-normal shape, but this question is about the sampling distribution. Okay. Now, the central limit theorem says that as long as the sample size is sufficiently large, that is, n is at least 30, then the sampling distribution of X bar will be approximately normal. Okay. So that's going to be the shape, approximately normal. Part D. Find the probability that the average, so when they say average, they're talking about X bar, right? So find the probability that the value of X bar exceeds $55. All right. So we can answer part D because we know that the sampling distribution has an approximately normal shape. Its mean is 50 and its standard deviation is 2.83. Okay, and the question is the probability that it exceeds $55. So that means greater than or equal to 55. All right, let's label this distribution. This is the sampling distribution of X bar. Okay. And we can even write some notation here. We want to find the probability that X bar is greater than 55. Okay. All right, so to figure this out, we need to standardize. Let's erase this here. Okay. So we need to find the z-score. So value minus mean over standard deviation. That's going to be 5 divided by 2.83. Okay, so about 1.77. Okay. And then from here we can use table A to get the area. Okay, so 1.77. That's negative. Okay. 1.77 is 9616. Of course, this area refers to the unshaded side, so we're going to have to do 1 minus that in order to get the area of the shaded right tail. And that's going to be 0.0384, so just under 4%.